Good afternoon and a very warm welcome to today's SK Online Academy Additives. To be more precise, small addition, big effect. Reduce the use of coatings and specialty sands with engineered sand additives. My name is Ismail Yilmaz. I am the Technical Product Manager for Sand Additives and I will guide you through today's webinar. The speaker for today's webinar is our estimated colleague, Dr. Reinhard Stötzel, who holds a PhD in chemistry. He used to be our SVP for coatings and additives, and thus was leading the product lines for more than 20 years at SK. Though he officially retired 3 years ago, we still enjoy his helpful commitment for our business and are grateful for his contribution. He is not only one of the most cheerful personalities within the foundry industry, with almost 40 years of experience, he is widely regarded and respected as one of the leading experts in this field. Reinhard will enlighten us today with the development in the field of additives. Dear Reinhard, it's your turn.
Thank you very much, Ismail, for your kind introduction. Dear participant, also from my side, a warm welcome. I would like to structure the webinar in following steps. First, some insight about the basics of sand additives, then how you can improve your productivity, followed by a session about how to have coating-free castings. Then I would like to show you some session about special sand, how we can reduce or eliminate it, and finally, how we can use additives in aluminum castings, and finally, a conclusion. What is the reason why you as a foundry man want to use sand additives? Certainly, it's a prevention of casting defects, for instance, veining, which is often a side effect of cold box bonded cores. But in general, you want to stabilize your casting production. But there are more reasons and more wishes you as a foundry man have for new additives. One is certainly the substitution or reduction of special sands. The other is an improved core box cleanliness to get higher productivity because of less downtime of your core shooter. And where possible under certain conditions, you would like to have coating-free production. In aluminum castings, certainly the shakeout improvement is a topic, and for steel castings, a reduced hot tear tendency. What are the different types of additives? On the left side, you see organic additives, which we call Weno. In the middle, inorganic additives, which we call Isoseal. And on the right, hybrid additives, which we call Weno Ultra. Almost all of these current existing additives are in the form of powder or granules. What are the features of these different additive types? Organic additives, which are composed out of hardwood plant-based granulate, dextrin or starch, are dosed in a relative low level of 0.5 to 5%, have good dosing properties, are very effective against veining, and of course are made out of renewable raw materials. But the opposite side is because of the porosity of these minerals or of these raw materials or the fineness, you have mostly to impregnate it with a resin to avoid a loss of strength. The other negative point is the high gas and odor load, the tool contamination, and the production of these additives is expensive because they have low bulk density. Inorganic additives are composed out of iron oxide, ceramics, or minerals at a relative high dosing level of 2 to 12%, They show almost no gas emissions, and usually there is no increase of binder necessary. Coating-free casting is possible, and you have a reduced tooling contamination. On the negative side, there is a high addition amount, as already mentioned, and the high raw material cost of these inorganic raw materials. Hybrid additives, as a mixture of organic and inorganic raw materials, are dosed at low level between 0.5 and 5%, show lower gas emissions, provide coating-free casting process, have a low tendency to deformation, reduce the tool contamination, and are capable to replace special sands. Partly, they are difficult to dose, and maybe you have to consider an impact on the core strength. How do these different additives are working? The organic additives, the components inside are burning, carbonizing, or softening so that they leave space for the expanding sand. They are typically used for iron castings, brake disc, brake caliper, hydraulic parts, engine blocks, and they are not capable to do coating-free production. Inorganic additives form a pasty transition phase or sintering phase, and these minerals act as buffer against the silica expansion. They have increased hot tensile strength and improved thermal elasticity, and due to the non-wetting properties, the alloy cannot wet the silica sand, which makes very nice surfaces. And substances with lower expansion factors lead to less stress. And if there's substances inside with higher thermal conductivity, this leads to a heat dissipation on the rim zone and thus also to stress reduction. They are suitable for steel, brass, and iron castings, turbochargers, engine blocks, and hydraulic parts. And coating-free production is possible with these inorganic additives. Hybrid additives, as a mixture of organic and inorganic raw materials, are combining both positive aspects of both additive types. With these, usually you have a high potential to save process cost. You have the opportunity for coating-free production. You can reduce investments. There is a possibility to replace or reduce special sand, and you have less fettling costs and are even more competitiveness against the other additives. These additives are suitable for iron and steel castings, brake disc, brake caliper, hydraulic parts, engine blocks, cylinder heads, and as already mentioned, you can do coating-free production. You certainly would like to ask me which is the best additive and at what amount. This question is not easy to be addressed because you have many variables which you have to consider. There's the molding material, the binder type, binder amount, complexity of the casting, the machines, the alloy, the casting conditions, the type of coating, people are involved, and you have environmental influences and demands, and so on and so on. In general, we can say all of these three additive types, you can produce good castings, but it's mostly an individual solution which you need. To give you this opportunity, we have a checklist developed which you can get from us. Coming to our session about how we can improve productivity in your foundry. We have developed new innovative engineered sand additives and approached an innovative foundry which is producing 170,000 tons of casting, ductile and gray iron, up to 5 million cylinder blocks for passenger cars. The demand was a low addition quantity of the additive, good anti-veining effect, dimensional accuracy, a very good sand flowability to ensure the optimum contour accuracy. They want to have improved core box cleanliness to reduce the downtime of the core shooter, and less demand for release agent. And last not least, a reduction or substitution of special sands. The additive composition was demanded to be ideally inorganic or at least hybrid, and definitely lithium-free. Maybe you have heard that the lithium minerals, which are often in inorganic additives, have boosted in the last 1 to 1.5 years by a factor 3. So your costs are exploding. We have developed this Veno Ultra 2000, which is patented. And if you look on the left side of the picture, you see the sand mixture, which is in yellow with the binder and the additive. Unfortunately, often sand is sticking when you strip the core out of the core box. We have developed an additive which contain an intrinsic release agent so that the core can strip without any residue out of the toolbox. This is not only a story, we have proven it in our pilot foundry. As you see here, we have a toolbox and we did 20 shots without any cleaning. On the left picture, you see the sand mixture with no additive. In the middle, you see a sand mixture with 2% standard additive of previous process from competition. And on the right side, you see the toolbox with 2% Veno Ultra 2000, and you see almost no residue after these 20 cycles without any cleaning. If you want to have it in numbers, you see it here. With no additive, we had in the toolbox 0.5 grams of residue. When you went to Veno Ultra 2000 with 2% addition, we were capable to reduce this residue by 55%. And if you go to 3%, you can reduce it even by 80%. That means almost nothing sticking in the core box after 20 cycles without any cleaning. So this was very convincing, and you see the casting result on the left side with the conventional system on the top. You see still some waning and some penetration, whereas with the Veno Ultra, it's a very clean casting. So this led to the situation that Veno Ultra was implemented in the foundry at low addition rate. There was no resin wipe off, and we had a very good tool cleanliness. The release agent was possible to be reduced, and we had a very good flowability with excellent anti-veining effect. And we were capable to reduce and replace various special sands and other sand additives at a very good dimensional accuracy. What's about coating-free casting when we use additives? Here we have an example. You see on the picture the brake caliper which is casted out of ductile iron before it was coated with our coating, and we substituted the coating process with our additive Reno Ultra. And the casting quality and surface was good that they can sell these castings. Here another example of a suspension frame previously coated, now uncoated with Reno Ultra. And another example, a wheel part of a truck, again in ductile iron, before coated and now without any coating process with Reno Ultra. And we were even capable to do the uncoated process on a gray iron casting of a 250 grade gray iron with 120 kilograms weight before it was coated, and now with additive EP4874 we have achieved very good casting quality. This is really a huge cost saving. If you look on the bottom bar, this is a situation with coating. You have the coating material itself, but you also have the coating preparation. You need manpower and you need drying energy. And as you know, nowadays energy is very expensive. So that means it's a big cost issue. If you sum all these costs together, we sum it up to 100%. When we implemented EP4874, the coating costs for material and also for the preparation and drying has been gone. Of course, you have the material cost for the additive, but at the end, we ended up by 64% of the previous cost. So you can imagine this is a huge, huge cost saving, especially now when energy is a real topic to be saved. Coming to the next section, how to reduce special sands. We did casting trials in our pilot foundry. You see on the left two pictures, how we did it with a step cone, and on the left larger picture, you see the situation with 100% reclaimed sand. Half of the step cone on the left side of the step cone was coated and the right half was uncoated. And you see on this right half, there's a lot of veining and a lot of penetration. So the foundry was using feldspar sand, J28. You see there is no more veining, but still some penetration. And then we took the 100% reclaimed sand, put in 5% Reno Ultra 3030, and you see a very clean casting with only minor penetration, even in uncoated condition. This was very convincing for many customers, and we implemented in this example these additives in a cylinder head water jacket core. The standard production was produced with more than 70% special sand. We were capable to eliminate the special sand by silica sand and our additive Reno Ultra. that there's a huge cost-saving potential you can see on the material cost if you have chromite sand or cerobeads, zircon sand, chamad sand, bauxite or kerphalite. You see there's a huge cost involved, even with a feldspar sand, with a J sand. But if you switch to silica sand and Veno Ultra, you really can maximize your cost saving in your foundry, in your core shop. And here, a very illustrative example of a European foundry. Before they used special sand in the value of 800,000 euro per year, we substituted it by silica sand and additive, which summed up to 90,000 euro. So at the end, they saved 700,000 euro per year. So it's a huge sum, 700,000 euro per year. Make use of it in your foundry. This is an example of a steel casting. Initially, it was produced in cold box cores with silica sand and uncoated condition, but there was a lot of sand erosion and hot tears, as you can see on the left picture. Then we introduce our Veno Ultra RS4, and we have seen that there's practically no erosion anymore and up to 50% less hot tears. What about additives for aluminum? You as an aluminum foundryman certainly would like to demand that the shakeout with cold box cores must be improved, because this is a big issue often. And you would like to have a low addition rate of the additive. For the additive formulation, definitely we need to have an inorganic additive because of the gas sensitivity of aluminum, and we want to have lithium-free additive because of the cost boost, which I mentioned before. We did again trials in our pilot foundry, and you see on the left column of the left picture the situation with the sand and the binder and no additive. Deliberately, we used a high addition rate of the binder to provoke a bad checkout in our pilot foundry. On the right bar, you see a mixture with 1% Isoseal 1010. Then the cores have been used uncoated at a casting temperature of 650 degrees. After pouring and cooling, we did the shakeout with a pneumatic hammer with 2 bars and 3 seconds per stroke. And you can see on the left picture with no additive that even after 10 strokes, there was still remaining cores in the cavities. Whereas with the Isoseal 1010, we have a clean casting already from 5 strokes on. This could be confirmed in several foundries of aluminum foundries, and we have seen that the shakeout time with 1% Isoseal 1010 has been reduced by about 50%. Let me summarize. We could achieve a huge improvement in productivity by reducing casting defects, scrap, and rework, and of course also by eliminating the coating process on ductile iron castings. Concerning economics, the elimination or reduction of special sand will bring you a lot money on saving, you will have reduced process cost. For instance, when you eliminate the coatings, when you have less downtime of your core shooter, or if you have less consumption of release agent. And with the substitution of lithium-containing additives, this will save you another big amount of money. Finally, in technology, certainly you will have improvement on environment and performance and sustainability of your casting, but also of your foundry. And finally, we will have increased quality and effectiveness. Thank you very much for your attention, and I'm open for any question.